Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start lecture number 29, and in this lecture we will continue Windows 32 console programming. Before going to start lecture number 29, we will review what we did in our previous lecture. In our previous lecture we covered two topics, macros and the Windows 32 console programming. So in macros we saw that how we can define macros inside the assembly programs, and then how we can invoke macros in the main program or assembly program. Then we discussed how we can write Windows 32 console programs, and we also discussed few functions, Windows 32 console functions and the handles. So we discussed about the background information, what is the Windows control program, what are the APIs and SDKs, data types in Windows, and how we can relate those data types with the assembly data types, and the standard console handles like input, output and error handle and so on. And we also did few examples, saw a few examples and the prototypes of console input and console output. In this lecture we will continue the Windows 32 console programming, and here we will see what are the other functions which can be used for file creation, file deletion and file writing and so on. So how can we create a file, how can we read file, open file and write information on a file and so on. And then we will discuss about the console Windows manipulation functions, like the text screen that you see, the black color. So how can we manipulate that screen, and after that system time and date, like how we can get local time and set local time, and the timer functions like the how tick, count, sleep and the date functions and so on. Then we have the graphical window functions. We can define our point or rectangle structures, which we also did in our previous lecture, like the coordinate structure. If you remember, there was coordinate structure and there were two members, X and Y. So that structure we already defined. However, there are some other structures, point and rectangle. Then we have the message structure, and then the Windows class structures and message box. So this is the message box function, how we can create the message box, like when you get some errors or something in Windows, you get this small message box. So here is a cross, here is minimize, the restore and maximize and so on, and minimize, plus here are some OK button or cancel button and so on. And then how you can define main window and the Windows procedures. So these are the topics that we will cover during this lecture. Now, file manipulation. In file manipulation there are different functions in Windows 32 API that are used to create, read and write file. Even though you can close file, you can open file and so on, but here we will see few of them, and the rest is very easy, so you can easily cover from your reference book and so on. Create file, read file, write file and the set file pointer. Now first of all, create file. It will either create a new file. This function can either create a new file or open an existing file. So in case if this function is successful, it will return the handle. So as we discussed, that this handle is more important. So it will return the handle for the open file. So if you are creating a file, it will be open and we will have the handle. So this handle will be used when you want to write some file, write information inside the file, or when you want to read information from the file, or even though if you want to close that file. So we need this handle information. In case, for example, if it fails, it returns the value or a special value that's called the invalid handle value. So for example, if you are going to write a file, open a file that is not there, so in case you will get the invalid handle value. Now this is the prototype. So here you can see the prototype. So create file, and first of all here is the name of the file. This is a P file name or pointer to the file name. This file name is a string variable. File name is a pointer to the string variable or a string array, whatever you can call it. In that, the file name can be a full file name and simple file name. Means file name with the path, like we have the drive and then colon, then backslash and so on, subdirectories, and then the file name. In the desired access, you will define the access mode and then share mode, then security mode and creation disposition, and there are other parameters that you have to define. So we will discuss them in the next slide, because there's a huge list, so you can see them, and after that you will see the example. However, when this function is successfully executes, it will return the handle into the EAX register. So what we do, we just save this one inside a variable somewhere for future use. Whenever we create a file or open a file, we get the handle, and handle will be saved in a variable, so that because EAX is always being manipulated by the microprocessor, so we always save it inside the variables for the future use. So here is a list of all these parameters that are being used in a create file. So we have the file name. So this can be null terminated string that contains either a partial or fully qualified full name. So we can have drive, we can have path, and we can have file name, or simply we can have a file name also only. So this file name can be any name, like abc.txt, output.txt, input.txt, and so on, whatsoever the name you are going to decide for the file where you want to read or write information. Then we have desired access. So it will specify that how the file will be accessed, either for reading, either for writing, or either for both purposes. So there are different attributes that you have to define for this parameter, like different values for this desired access. Similarly, the DW share mode, so it can control the ability for multiple programs to access the file while it is open, like you want to restrict only for the write, or you want to restrict only for the read and so on, or you want to restrict only for delete or something and so on. So there are share mode also. And then there's LP security attributes. So there are security attributes for controlling the security rights. And then creation disposition. So in this creation disposition, it specifies what action to take when a file exists or does not exist and so on. And then DW flag attributes. So there can be flags for like either the file is hidden, file is like normal, system, or temporary, or encrypted and so on, or maybe archive and so on. And then the last one is called the template file. So this can contain an optional handle to a template file that supplies the file attributes. Means one file is already created, so you can use the template of the same file for the new file when you are creating it. So here you can see desired access. So it will let you to specify either you want to write, read or write and access, or device query access to the file and so on. So here is 0. It defines the query access to the object. So the application can query device attributes without accessing the device and so on. And then we have generic read that specifies the access to the object. Data can be read from file, and the file pointer can be moved and so on. It can be combined with the generic write. Similarly, generic write can be combined with generic read, so you can perform both read and write functions and so on. And then we have DW share mode. Here in DW share mode, it will have different 4 values. Either it can be 0, 1, 2, and 4. So you can hexadecimal 4 and 1 and 2, and this one is hexadecimal, all these 0, 0s and 0. So these are the values that control the ability for multiple programs to access the file while it is open. So either you want to open file share for delete, for read. When you open for 0, so it will prevent other processes from opening a file or a device if they request delete, read or write access and so on. So you cannot perform any action on that one. And even, for example, if you want to perform delete or rename the file, So you have to use the file share, delete, and so on. If you want to enable the subsequent open operation on a file or device request to read access only, then file share read will be used similarly for the write and so on. Here the creation disposition, it will specify which action to take on an existing file, on a file that exists, and which action to take when the file do not exist. So here is either create new, create always, open existing, open always, and truncate existing, and so on. So create new, it will create a new file if you are using this one. If the file already exists, then the file it will fail, the function will fail, and so on. So create always it will also create a new file. However, if the file already exists, the function will override the file, whatsoever the previous information is. So it will erase that one, and if you are going to open for a new writing data or reading data, you have to define what action you can perform. However, previous data will be removed, and so on. And open existing, it will open the file only. It will not create, but it will open the file, and the function will fail if the file does not exist. So it may be used for reading purpose or writing to the file, and so on, if you are going to open existing, and so on. Similarly, if you want to create a new file with create new or create always, then you can open for reading or writing or both purposes, and so on. So similarly, there are different functions. So all these functions you can, there are different parameters. You can see on MSDN library. MSDN library for brief explanation about all these functions and their parameters. Now here we have the flags attributes. These are the most commonly used flags and attributes, which are shown in the following table. Here you can see this is not the complete list, still there are so many other attributes. So we can have attribute archive. So, and then we have hidden file, we have normal file, we have read only, we have temporary file, and so on. So it depends how you can define the attributes of file. The file can be read only file, so application can read the file but cannot write or delete it. If it is like normal, the file has no other attribute set, so attribute is valid only if you use it alone. Here you can, these like hidden and random, you can combine these attributes. Now before going to move further, I will show you one example how you can combine files. For example, I want to make the file attribute read only, and if you want to combine another attribute here, then you can write it here. So you can use plus sign and so on. So if you want to access multiple attributes, if you want to read open a file with reading and writing options both enabled, then you can combine them by using plus sign, and there are other methods also, but this is the most convenient one. So here is the example. Here you can see we can open an existing file for reading. How we can open? So this is the invoke create file, this function, name of the function, we are calling this function. Now this is the address of the file name where you define the file name, so you can create it, the file will be created. Generic read, this is the access mode, so we are opening this file for generic read. And we have the file share read, so is the sharing mode, so how you are going to give the how or for what purpose you are going to open a file. This will define that purpose, like we are only opening for the reading. And then we have the null option, so security attributes, you cannot have any security attributes, and so on. Mostly it depends what type of security attributes you want to use. So mostly it is null, we use them for text files and so on. Otherwise you can enable different security attributes. For full information, you can go to the MSDN library and you can see what are the security attributes. Because due to the limited time, I cannot cover all of them here. So open option is the MSDL library. And open existing means file creation options. In the open existing means this file will be opened, whatsoever the file which has been defined in the file name, and it has been saved somewhere on the drive or somewhere. So we are going to open an existing file. So it will open an existing file, and the attributes are normal. So these are the normal attributes that you can use. And the handle to the template file, we are not using it, so we can call it, or we can use it as a 0. Now, so we are going to open an existing file for writing purpose, not for reading. Previously it was for the reading purpose. Now we are going to open for writing purpose. Now here you can see we can have all the options similar. Create file, and we have address of the file name, and the file name may be with the full path or simple file name. So generic write purpose we are going to open, and then we have file share write. So access mode is only for the generic write, and file share is write, and this one is the security option is null. Open existing means we are going to open a file, not we are creating a very new file. And the file attributes are normal, and the rest of the options are almost similar. Now the third example is if we create a new file with normal attributes and erase any existing information, erase an existing file by the same name. So what we do, we will create a new file. If there is a file already available on the drive, it will be erased, and a new information will be written in that file. So here you can see the same file name. Write purpose, we are going to open file write purpose. Security option is null. So this one is the create always. Create new, create always, and create existing, and so on. So depends what option you are using. If I say create always means whatsoever we are forcing it to always create a file. If there is a previous file, delete it and write a new file, and so on. And this one is for the read file. So previously whatsoever we studied, it was only for the file creation, or maybe you can open a file. However, now when we open a file, definitely we want to read or write something, some information inside the file. So here is the read file read file function. Inside read file function, we read text from an input file. So we are going to open file as an input mode, and we can read information. Why we call it input file, even though we are not writing, but we call it input file. I will discuss later on the concept. So before that one, you can see what is inside this prototype, or what is the prototype of this function. So here, read file function, there should be a handle. This handle you will get from the create file when you are going to create an existing or create a new whatsoever. So you will get a handle. You must have to save that handle. So after saving that handle, you have to use that handle here. So this handle should be you will get from the create file procedure. So create file, you can see that create file can create file from the existing file or maybe a new file, and so on. So this handle should be you will get from the create file, and you have to use it here. Now we have the buffer, pointer to the buffer, and this is the byte. So this is the information that you are going to write inside the file. And then we have the third option, or the third parameter is called the buffer size. So number of bytes you want to read. So this is the buffer area. So this is the buffer area where you will write information which you are reading from the input file inside this buffer. Now here you are going to open a file, and this file is considered as an input file from existing input file. Read text from an input file. So we are going to open a file, and file name is, for example, abc.txt, and now after that here is the buffer area inside the memory, and you will read information at this point, and then you can display information and so on, whatsoever you, for what purpose you are going to read information. Then you have to define how many bytes you want to read, and here the second, third, fourth option will give you the actual number of bytes you have read. Maybe you are defining 100 bytes, and for example it is going to successfully read 20, 40, 50, 80 or 90, or maybe out 100 bytes successfully have been read or transferred to the buffer area. So this parameter will indicate how many bytes you have read. Then overlap is used as a pointer when you to synchronize, asynchronize information and so on. So if you don't, we mostly do not use this one. This is used when you are synchronizing with device or something and so on. So we can write it as a 0. So overlap is also in the write file. So write file, it will write data to a file using an output handle. Using an output handle, the handle can be the screen buffer handle, or it can be one assigning to a text file and so on. So the prototype is write file proto, file handle. So this is the same file handle which you will get from the create file and so on. And we have the buffer. This is the information which we are going to write inside this file. And then next we have the buffer size. This is total size of the buffer, how much size of the buffer is there. Then bytes, how many actually bytes have been written out of these whole number of bytes. So maximum number of bytes written should be less than or equal to the buffer size. And then this is the same option where if we are not using, we can use it as a 0. Now we have the file pointer. For example, sometimes we want to move our cursor, or we have a very large file, mostly in random access filing. This is a complete file, and we have so many bytes, or maybe the formatted information is stored inside this file. So we can move our pointer here, either starting of the file or maybe end of the file, or maybe somewhere here inside the file, to jump directly there and read information, read number of bytes from there. So we can define a file pointer by using the set file pointer. It moves the position pointer of an open file. You can use it to append data to a file and to perform random access record processing. So that, as I told you, so random filing, for random filing or random file access, we use the this type of set file pointer. So there should be handle. The handle should be you will get from the create file and so on. And this is the distance, low bytes to move pointer, how many bytes you want to move the pointer. Pointer, how many bytes have been moved. So this is the low and high. So pointer to the bytes to move and so on. And then move method is the starting point, either the starting point or the ending point from where you want to move. So for example, if we move from here and some number of bytes, or if you want to move from here to some number of bytes inside the file and so on, and it will set there the pointer, and from this pointer you can start reading or appending a file and so on. So here is the example. Here you can see set file pointer. This is the file handle 00. So we are not moving the number of bytes, but what we are going to do, we are just transferring control, or we are moving cursor to the starting point, that is the file end. So our cursor will come here, or the file pointer comes here, and we are not moving further, like from here upward or downward you cannot move, but you can move upward and so on. So in this way you can move file pointer to the end of the file, and you can append data there and so on. So here is a very simple program. In this program you can see we have defined multiple, we can create a file, we can ask user to input any value. So now here you can see this is a program, the very simple program. In this program you will see how we can create a file, how we can write information inside a file, and how we can close a file. So here we define the buffer size, is 501 bytes and so on. So buffer is created. Byte in buffer is a area or the memory reserve or variable that will have the 501 bytes, and we are not defining or assigning any value to this one. Then we have the file name. This file name is a byte type and it is null terminated string. And then we have file handle. It's a type of handle, then string length and the bytes written and so on. So here you can see that we are going to create a new file. How we can create a new file? We write CreateFile, invoke CreateFile, file name, address of the file name, generic write purpose, and this is the sharing write. So file share for write, and the security is the null, and create always, and file attributes are normal. So here we are going to create this file, and when we create, if the file has been successfully created, so share, this is the create always. If there is already existing file, it will be deleted and the new file will be created with the same name. And whatsoever, if this function has successfully performed its execution, then EAX will have the handle. Now this file handle variable will hold this information, because EAX will be modified in the program. So what we are going to do, we are going to use this handle or store this handle in variables so that we can use it further. Even though you will see when we are going to write a file, then we will use this function, this handle. So this is the only area where we create a file. Now after that, we ask user to input some information. Here you can use, at this point you can use the console functions to read file, as we saw in our previous program, and you can use the stdin and so on. So we are using stdin, for example, very quick one. So invoke stdin, address of the buffer and buffer size and so on, and whatsoever the number of bytes you will enter, this for those number of bytes or characters or string will be transferred inside the buffer, and EAX will hold the number of how many number of characters, what is the size that you input inside the buffer, or how many keys you have typed, and EAX will hold that value. And now we are going to move that information also into the string length. Now we have got the buffer, we have created file, we have stored handle, we have got the information that we want to write, and then we have the EAX that will hold the total size of the buffer, how many bytes you have entered, and that is stored in the string length. After that, we are going to write a file. So here you can see EAX was holding previously the file handle. Now EAX is holding the number of bytes you have entered. Now after that, what will happen? Again, we need the file handle. So if we need file handle, then definitely we cannot use EAX, because EAX has been modified here. So we are using this file handle. So directly you can use file handle here if you want to use. Otherwise, we have defined some, we have moved inside the registers, like file handle is moved in EAX, offset of buffer, and is moved in the EDX. You can use the address, this option, like the address. Here we can use offset, but here if you want to use here, so you have to use address, buffer, and so on. Then ECX has the string length, the number of bytes to write, and then address of the write to file 1, it will give you the total number of bytes that have been written inside the file and so on. So we are going to write information to the file. Now at this point here, you can see we have not defined any name of the file. There is no file name. Here is, we have only one, the file handle is there. So we have got this file handle. This file handle will be used for whole time until you are not going to close a file. So this file handle will be used as a reference to deal with that file. Either you can perform reading, writing, or other operations. And buffer pointer is there, the information you are writing, and then we have the number of bytes that we want to write, and it will return, this function will return us how many bytes have been successfully written. and we are not using this last option, overlapping option, and so on for asynchronous operations. After that, when we successfully write, for example, if I want to print that how many bytes have been written, so this EAX will give us the number of bytes to be written. So this is the return value, so I can move this one. So this is write file 1. It will have value inside the EAX. So this write file 1 will give us how many bytes have been written. So I want to save it in EAX and convert it into the ASCII, integer value into the ASCII, and so on. So I want to print it. So I want to use, for example, same buffer area, and I want to print that how many bytes have been successfully written. And after that, in the end, we are going to close a file. So here you can see the same file handle can be used here to close a file. So instead of using EAX, you can write address of the file handle and so on, or you can move into some register and so on. So if you want to close a file, then we have the close handle. So we are not closing a file, but we are closing the handle. If you close handle, means we don't have any connection or a pointer that is dealing with the file and so on, or maybe with the IO devices and so on. But here at this point, we are going to close a handle that is dealing with the file. So if you close the file, close the handle, it means file will be closed and so on. So this is very simple example. We can open file, and then we can save this handle. Then we can read information that you want to write inside the file, and then you are going to write information, the buffer information, whatsoever you got inside you can write that information inside the file. Then you want to see how many bytes have been written, and then you close the file and so on. So after that, we are going to have the one concept, as you have seen, that we can use open file for output handle and input handle. So here is the input file and output file. So I will explain here what is the difference between input file and output file. For example, if you want to write a file, actually we define memory area. Input file when we read information. If you want to read information, then it should be input file. If you want to write information, file should be open in output mode or output file. Now this concept is also used in C or some other languages, C or C++ or other languages. What is this option? We have file and we have memory area. So we are going to open a file into the input mode. So these modes are referenced with a reference in perspective of the memory. Now if you are going to open a file and if you want to read, actually what you are going to do, you are going to input information inside the memory. Now after that one, if you are going to write a file, and this information will go from memory to the file. So this movement of information from memory to the file is called the output. So this input file or output file are referenced as in perspective of memory. So how information will be either moved from the memory to the file or from file to the memory. If file to the memory, then we call it input. Then if memory to the file, then we can call it the output, and so on. So this is the perspective or the reference that is being used when you open a file for reading and writing and so on. So we can call it input file and output file modes and so on. So the next section we are going to cover here is the console window manipulation. This console window manipulation is the same window as the window, black color window, where you can see the text output. So it is only the title bar, then here minimize, maximize, and the cross and so on. So here there is a simple text. So all these functions they will be used to manipulate this console window. So we can have the screen buffer area, then console window, and then controlling the cursor and the controlling the text color and so on. Even though there are so many other functions, but right now we will discuss few of them. So a screen buffer and the console window. So here you can see the active screen buffer. So this is the screen buffer area. We have the whole screen. We have this whole active screen, complete active screen, and the area, the buffer area, or we can call it console window area here. This is called the console. So complete window is called the active screen buffer, and then we have the console window or area inside that that active screen buffer. So the active screen buffer includes data displayed by the console window and so on. And then what we do, we have the set console title. Now if you want to set the title of the console window or the console window, then what you can do here, there's no need for the handles in this one. So what you will do, you will write the string that will show the title of the which title you want to set for the console window and so on. And then we have invoke set console title and the address of the string that you want to write as a title. And this is null terminated string. It will be passed inside this. This is the only parameter that you can pass inside the set console title. And this title you will see on that window. It will be changed. So whatsoever the title you will write here, it will be set on the screen. And then we have the get console screen buffer information. Now get console screen buffer information. So we are going to get the whole complete information of this window, that what is the total size and so on. And so it will return information about the current state of the console window, whatsoever the current state, if you have minimized and maximized and so on. Minimize means you have reduced the size. So the number of columns and number of rows depends on the size of this window. And it has only two parameters. This so get console screen buffer information, it has only two parameters: a handle to the console screen and a pointer to the structure. Now here there are so many options, so many operations that you so many options or so many properties of this window to handle. So what we do, this function will receive the structure. Now what is the structure? The name of the structure is console screen buffer info, or you can define your own structure. However, you must know what type of members of this structure should be there, or what type of information will be returned by the console screen buffer function. So first one is the handle. This handle, for this purpose, we need a handle to this console window. So what we do, we can say invoke get standard handle and std output handle and so on. So we can get the handle here by using this one, and the same handle you can use it here. So the same handle can be used here. Now this is the console info structure, or console info structure, that will hold all the information, all the parameters. Very simple one. Now we have to see what is inside this structure and what are the members of this structure. As we already know how we can define structures, how we can assign or create the members of this structure. Now this is the console screen buffer info structure. First one is the DW size, then cursor position. So these two, size and cursor position, are of type coordinates. Coordinate is also a structure. As I told you previously, coordinate is a structure which has values for the x and y value. And then we have the small rectangle is also a structure. It has different value. The starting position here, this one, and this information. A starting position here and this one. So this will define the small rectangle. And we have the window size. So we have again the coordinate structure. And then attributes is a simple word. So we have 1, 2, 3, 4 and 5 members. Out of them 3 are coordinate structure, 1 is a small rectangle structure, and then the 5th one is the attributes. Now size is the size of the screen buffer. So it is the character, columns and rows. So character means how many characters in terms of columns and rows are there inside the screen buffer information or in screen or console window. Then we have the cursor location. It will give you the current location of the cursor in the XY coordinates inside that console screen. And then colors of the characters in the console buffer. So color, for example, right now we use white color, so it will give you the color information for the characters which is currently active there. You cannot have multiple whatsoever the last color that have been set or whatsoever the color is currently being used. And then the window is the it will give you the coordinates of the console window relative to the screen buffer, so and so on. And then the maximum size of the console window will be given or stored inside the maximum win size. So this is complete structure here you can see, and it is also using different other structures and forming a whole complete structure. And this structure or variable of this structure type or this type are passed inside that function to get whole information about the console get console screen buffer info. So this function will fill this console info, this variable of type this one, the console and screen buffer info and so on. So now you can use this information for what purpose you are going to use and so on. So set console, that was the previous one was the get console window information, buffer information, and then set console window information. If you want to set the information, it will let you whatsoever. So in the previous one you saw that what is the maximum size? Maximum size in terms of columns and rows, and you can define the XY mean the rectangle size also, you can define color also and so on. So the same structure can be used to pass parameters, or maybe the other structures like the coordinate structure or the rectangle structure. So here you can see we will use the set console window information. It will let you either you can resize, set the size, and set the position of the console window relative to the screen buffer and so on. So here in the set console window information is a prototype, function prototype of this function. So here set console window info function prototype is given. There are 3 parameters that are being passed. So first parameter is the screen buffer handle. So this is the handle information that you will use to set information, because before setting that screen console screen or console window, we have to get the buffer, we have to get the handle first, and then we can set information. Or first we have to get the handle, and then we can get information about that object and so on. And then we have the coordinate type, what you want to use. Then the second one is the rectangle, window rectangle. So we have the small rectangle structure that will be used to set the rectangle or the type of this or the area or the size of this rectangle or the window. Then the third one is the set console screen buffer size. Now this is the console screen buffer size. It will let you, it will give you the flexibility. You can set the screen buffer size to X, Y, X columns and Y rows. If you want to use X columns and Y rows, how many columns you want to use in the screen buffer size and so on. So what you have to do, you have to define the number of columns in X. So we have the coordinate structure. X will define the number of columns and Y will define the number of rows and so on, and you have to pass this information, so it will set the screen buffer size and so on. And definitely you have to get the handle information, so this handle information will be used to handle the screen buffer and so on. Then controlling the cursor. Now whatsoever we were dealing, it was how you can get the console screen and console screen buffer information and so on, how you can set that one and everything. Now here is how you can control the cursor, means how you can set the cursor information, like you can return the size and visibility of the console cursor. You can set the cursor console cursor information. You can get console cursor information, you can set console cursor information, and even then you can set the current cursor position inside the window and so on. So there are three main functions which deal with the cursor. First one is the get console cursor information, so it will give you the size and the visibility of the console cursor. Second one is the set console cursor. It is opposite, it will set all those values, whatsoever the values that have been returned by the get console and so on. And the set console cursor, you can set the position of the cursor at any XY position. So console cursor information, here you can see is a structure containing information about the console's cursor size and visibility. So console cursor, this is the structure that we will use. So console cursor info is a structure. So this structure will be used for all the purpose to get information and to set information about the cursor. So size and visibility information. Here is double word for the size and we have the visibility. So this is the structure and end of the structure for this one, and this structure will be used in the set console text attributes. So this console cursor info structure will be used if you want to set information about the cursor or get information about the cursor, and if you want to set the location of the cursor or its XY positions, you can use the coordinate structure and so on. After that we have the set console text attribute. So this is one of the functions that will deal with the how you can set the colors and the background, foreground and background colors of the text that will be written on the console. Means once you set, and then if you write something, then the colors will be written as it is, whatsoever you are defining here. After that, if you want to change again, for example here, if you write ABC, and before writing ABC you set some colors by using the set console text attribute, foreground and background colors for ABC, then they will be applied here. After that, again, if you want to change any color or foreground or background, and then if you are writing ABC, then this color will be changed for this only and so on. So here there are two parameters. First parameter is the handle, console output handle and so on. Then this one is the color attribute. So color attribute will define that the foreground color but which you are using here. Now the next one is the write console output. So it will copy an array of attribute values to the consecutive cells of the console screen buffer beginning at the specified location. Now here this is write console output attribute. Function will write information which copies all the arrays of attributes. So we define all the attribute arrays, for example the colors and so on. So these colors or information will be set for all the consecutive cells, and then you can specify the location where you want to apply that one. So here you can see we can have out handle. So this is the handle for this one, and then we have the attribute. So we have the write attributes, and then we have the number of cells, and then we have the first cell coordinate and the number of cells written and so on. Here is one example. If you want to see this one, create an array of characters and an array of attributes one for each character. For example, here you can see we have number of characters here. These are the different characters, and we set an array for all these characters which you want to print here, and attributes are also set. So what we do, we copy the attributes to the screen buffer, and then it will copy all the characters to the same screen buffer cells as the attributes and so on. So this code is available in the file in the book. If you want to see, it's a very simple code, and you can easily understand that code. Now after that, we have the time and date information, or time and date functions, the functions that handle time and date. So here you can see we have the get local time, set local time, get take count, we have sleep, and then we have the get date and time. Then we define the system time structure, and you can have the there's one example inside the book about the creating a stopwatch timer and so on. So get local time and set local time, there are two functions. First function get local time will return the date and the current time of the day according to the system clock, and then the second one will set the system's local date and time and so on. So here you can see the prototypes. Get local time prototype, we will define the system time. So we have the structure. This structure is called the system time structure. So once you define this structure, we can define these values of for the members, or you can use that structure to get the values from this function and so on. So this structure will be passed as an argument to this function, and also when you pass this argument, this function will append write all the member information, or append all the members information. And after that, if you want to see what is the date and what is the time and so on inside the members. So we will see what are the members of the system time structure and so on. Set local time, whatsoever the values you have defined for this for the members of this system time structure, their values will be written into the system clock and so on. Then we have the get tick count and sleep. The get tick count information, or this function, it will return the number of milliseconds that have lapsed since the system was started. So since the system started time, how many clock counts or tick counts have been passed or have been completed, it will give you the whole information. Then we have the sleep function. It will pauses the current program for a specified number of milliseconds. So get tick count prototype, it will return the value in the EX, how many tick counts after the system startup. And then sleep prototype will accept only one value, that is called the milliseconds in double word. So if you define number of milliseconds, it will sleep for that time, or it will pause the thread for that time and so on. Now one thing, you have seen that we are using system time structure. In this system time structure, is used by the date and time related Windows API functions, as you saw in the get local time and set local time and so on. What is inside this? So here you can see get local time and set local time, they are using both the system time and so on. So in this system time structure, there are multiple members. First member is a year, second member is a month. So this year is a double word, and there are year is a 4-digit value, and month is 1 to 12. So it can be month 1 or 2 or 12. So it can be 1-digit or 2-digit information. So we have month, then we have days of week. It can be 0, 1, 2, 3, 4, 5, 6 and so on. And then we have day is the so this is like Saturday, Sunday, Monday and so on, all the days of the week. And then the day or the date. And then we have the hours, minutes, seconds, and then we have milliseconds. So if you define this any variable of this structure type, if you define, so first you have to define this structure inside the R1 include R1 library file. All these structures are already defined. So the book which we are using as a reference book or the textbook for the assembly language, they have the libraries, and all these libraries have these structures, predefined structures in their include file. So if you want to use that include file, you can directly, you don't need to define these structures and so on. You can directly use these structures. So here is the, if you want to create a stopwatch timer. So the next one is about the writing a graphical window applications. So inside the graphical window, so whatsoever we were dealing previously, it was about the console window or console buffer information and buffer and so on. Now here we are going to deal with the graphical windows. The window that you are seeing right now here, when we right click here, you can see the pop-up window and so on. In case of error, you will receive a window like our message box. As I told you, in a message box will be like this one, and here will be OK or cancel and so on. So this is, and so these are the graphical windows. So how you can write a program in assembly language to deal with all these graphical windows? It's very easy. Some people think that it's really difficult to write Windows applications inside the assembly language. However, it is really easy to write applications that are using graphical windows inside an assembly language. So what we will cover during this section is about there are two structures, point and rectangle. Then we have message structure, we have Windows class structure. So these are four structures, and then we will have the functions. Now to deal with the graphical windows functions inside the Win32 API, there are multiple, there are so many functions. However, we will cover only few because there is a huge list. Even though whatsoever we covered about the console, system, time and date, reading and writing files, whatsoever the file handling, these are the only selected are few functions that we are using from the Win32 API. There's a huge list. You can go to the MSDN library, you will find the complete list or information about all those functions, and it's really difficult to cover during these lectures. So I will give you only introduction about few which are very common, which we use, and then rest is very easy for you to cover when you just go through all those functions. Now here we have four structures and three functions that we will use to handle the graphical Windows applications. First structure is the point structure, point X and point Y. So it will give you the XY screen coordinates. It will either store or save or maybe set the screen coordinates and so on, or the points and so on. And then we have the rectangle. This will hold the graphical coordinates of two opposing corners. So this is the left, so from here to here, and XY position can be somewhere inside. So if you want to have rectangle structure, if somewhere we will use rectangle structure, then just remember there are four members: left, top, so this is the left, top, so left, and this one is top, and then we have the right, and then we have bottom. So all these are the left, top, right, bottom. These are the four members of this structure, and they will hold the value of like all these coordinates. Here you can see, if we say this is the x-axis and this one is the y-axis. So first one is the left, so it will be x1, y1, and then we have x2, y2, and so on. All this information should be there. So x1, y1, and x2 and y2, this information will be stored inside this rectangle structure and so on. Now we have message structure. Now one thing is more common, this message structure, it will hold the data for MS Windows messages. What are these MS Windows messages? This is the information usually passed by the system and received by our application. So this type of information is passed between Windows and by the system and our application. So what is the type of information that will be passed by the system is the message window, and then what's the message, what are the parameters, Windows parameters, and so on. We have time and the point and so on. So all this is the message structure. So this message structure will be used when we get some information from the system towards our application. Then we have the Windows class structure. Each window in a program belongs to a class. So for example, we have a main window, and then we have other windows like pop-up windows and so on. So each window in a program belongs to a class, and each program defines a window class for its main window. So we have main window, and then other windows are using that main window class and so on. So what is a Windows class? Is also a structure. We have the style, so Windows style information, Windows procedure function pointer, shared memory, we have the number of extra bytes, handle to the current program, handle to icon, handle to cursor, and then handle to background brush, pointer to the menu name, pointer to the Windows class name, and so on. So here all the information is inside the Windows class. So here you can see the style is the conglomerate of different style points, different. So the style is conglomerate of different style options, such as like WS caption, WS border, that control the Windows appearance and the behavior and so on. Then we have the Windows procedure, is a pointer to the function in our program that receives and processes event messages triggered by the user and so on. Then we have the class extra. Then we have the another then we have another option that will refer to the shared memory, or the memory that we are using, that is used by all windows belonging to this class. It can be null. So we have Windows extra. This specifies the number of extra bytes to allocate the following window instance and so on. And then we have a huge list of these options, members of this Win class structure and so on. Now we will come to very quickly to a very simple window that you can create. So in this one you can see we are using the window, then we have the byte for the text, we have caption, and then we have the style. So this is the message box function. This message box function will display a text in a box that pops up and waits for the user to click on a button. So there are multiple members. We have the window, a handle to the window, and then we have the text that you want to write. Then we have the caption that you want to write on the title bar and so on. Then we have the style. So in this one, we have the handle to the current window, then we have the text or null terminated string that will appear inside the box. For example, here if I write one structure, the picture of this one, so here at the here and here, this is the p text and this is the caption, and these buttons that you are going to use. So caption is a null terminated string that will appear in the box caption bar, and then style is an integer that describes both the dialog box icon optional and the buttons required. So we can describe the dialog box icon. Either you can use any icon or not. However, you must have to define the buttons. Now, for example, this is the very basic example that will create a window. It will display a message box that shows a question mark, that shows a question, including an OK button and a question mark icon. So here, first of all, we have the question text, then we have the question title, so title bar value, and then we have OK button. So these are the three. First is the handle. So we can use the handle like main window, whatsoever the handle is already created for this one. So we are using the same handle here. So invoke, message box, and then there's the handle information. Then we have the address, is the question text. So this will be used as a text inside the message box. Then this is the title that will show in the on the top of this address, the message box. And then we have the OK button and the icon for question and so on. So this is the very simple program. So we have the WinMan procedure. Now you can see whenever you create a Windows application, we must need a WinMan procedure. Now every Windows application needs a startup procedure. So for example, we are using the start and the end of the start complete program. However, we need a procedure that will hold all the Windows application information, and that is called the WinMan. So needs a startup procedure, and it is usually we write name the WinMan, which is responsible for the following tasks. First one is the get handle to the current program. What is the handle for the current program? Second one is the load the program's icon and mouse cursor. This is also important. Then register the program's main window class and identify the procedure that will process event messages for the window. So whatsoever the messages are being shared between sent through the system, from the system towards our program or application. So we have to define the register the program's main window class and identify the process event messages. Now we have to create a main window. So then we will create main window and then show and update the main window and so on. Then begin a loop that receives and dispatches messages, for example. Now you can create a main window. After that, you can continuously doing that one. So it depends what type of events you are going to create. For example, either you can click right click, left click, or key left click down, press up, and so on. There are different events, and you will receive all those messages from the system towards your main procedure and so on. So Windows procedure. This Windows procedure receives and processes all event messages relating to a window. For example, some events are initiated by clicking, dragging the mouse, pressing the keyboard keys, and so on. So Windows procedure decodes each message. So all these messages, when you press enter key or when you press any key, when you press or release mouse keys, this information will be sent from the system to your Windows and Windows class and so on. So all these events will be sent to your application. So Windows procedure will receive and process all of those events. So Windows procedure decodes each message, and it will carry out application-oriented tasks related to the message. Now here you can see we have the handle to the window and the local. So this is the message ID. There are different message IDs, and these are the parameters. So there are parameter 1, parameter 2, so it varies either how many parameters are there and so on. And the contents of parameter and the W parameter and L parameter and so on, they vary depending on the messages. Now this is the sample Windows procedure message. For example, one is the WM L button down, so it will generate when the user presses the left mouse button. Indicates when you create a window, so this is the Windows procedure message. It will be created when it will be sent towards your application when a new or main window is being created. Close the application when it will indicate that main application's main window is about to close. So there are so many other messages. There's a huge list of all these messages: left button, right button, left button down, right button up, left button up, and so on. So there are so many: create, close, minimize, and so on. So inside a min, so here's the message loop. For example, we are defining a message loop. Inside the message loop, we have main window, main procedure. Inside the main procedure, we have a message loop which will receive and displays or relays the messages and so on. So we have a message loop here, and we will jump always to this message loop, and we have to see what type of messages we are going to get. So we say get message. So we are going to invoke address of the message. So this is the message structure we already defined and so on, and all these parameters are null and so on. We have to invoke get message, and there is an address to this message variable, and then we have all the other parameters as a null. So for example, inside a queue we have message that if the information inside the EX is equal to 0 means jump to exit program. So it will exit from the program. Otherwise, if it will give you 0 in EX if there are no messages in the queue. However, in case if there are messages or there is another information like button has been pressed, so we say relay the message to the program's Windows main procedure. So what we'll do, we'll invoke dispatch message and address of the message. It will send information to the Windows main procedure and so on. So when the Windows main procedure receives each message and decides what to do, for example, here you can see into the Windows main procedure, we have the handle to the Windows, we have the local message word and so on, and we have the parameters V and L parameter and so on. So what we will do, we will have local message. Whatsoever we receive, it will be moved to the EAX, and if we say if EAX is equal to the left button down, if you press the down button or the left button or left click, then we have to create a message box, invoke message box. So we have the handle and we have the pop-up text, whatsoever the pop-up text you are going to define, and pop-up title and only OK button, and then we just jump to somewhere else. Otherwise we will create create a window. So we will create a window and we say invoke message box and so on. So and then we will jump and so on. So here you can see, first of all, we have a Windows main win-main function or win-main procedure, and then we will get all the information inside the win-main procedure. We can create message boxes, and also we can get the messages from the system inside a queue, and we can read messages from the queue. We can pass to the main window, and main window will handle whole information. Now this one is a very brief introduction about how you can do all these Windows programming or the window programming inside the assembly language. Now we are going to summarize what we did inside, or what we covered inside this lecture. Here we covered that how we can create what are the Win32 API functions that will create file, read file, write file, and set the file pointer and so on. So you can create file, you can read information from the file, you can write information inside the file. So when you read file information from the file, you have to file in the input mode. When you're writing, then file should be in output mode and so on. And we can set pointer to move our pointer in the random access mode and so on. So we can set pointer somewhere inside the file so we can directly read. Then we have console window manipulation. We can have a screen buffer, we can have console window, we can control cursor, we can control the text color and so on. Then we have about the time and date functions, Win32 API functions for time and date. We can set and get local time. We can get tick count and sleep. We can get time, and then we have the structure time and date structure, or we can call it system time. And we also discuss about the graphical window functions. These graphical window functions that will deal how we can write Windows programs which have the graphical windows inside assembly language. What are the structures that are being involved? The message structure and Windows class. These Windows classes there and message structures there, they will pass information from the system to the Windows main procedure. And we have message box function. This is very simple function, so you can get a simple pop-up window, small window with OK or other buttons and so on. Then we have Windows main procedure and main procedure, which will be used to handle the control main or handle or control the main window inside the assembly language. So this is overall information, overall discussion about the lecture number 29, and hopefully inshallah see you in the next lecture. And here's the reference. You can go through all this book, assembly language for Intel based computers, the 4th edition. So keep our Irwin, and the chapter number 11th is the chapter from where I got all these slides and so on. So this is end of the lecture, and inshallah hope to see you in the next lecture. So till next lecture, Allah Hafiz.